Okay, so 7.3, we're going to use proportions to identify similar figures. So we've been using proportions. We've actually been using scale factor, which we're going to talk about today. And we just didn't call it that, but we were using it. So the first thing is two polygons are similar if corresponding angles are congruent and corresponding side lengths are proportional. Angles have to be congruent, but sides can be proportional. Because I can have a triangle with the same angle measurements with different side lengths, it doesn't change the angle. Okay? Two polygons are similar. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called your scale factor. So scale factor is the ratio of the lengths of two corresponding sides. And that goes the other way. If corresponding sides are proportional, then the polygons are similar. Got that? Sense?
Sure.
Okay. So perimeter of similar figures of a polygon theorem. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of the corresponding side lengths. The ratio of the perimeters is equal to the ratio of the corresponding side lengths. That's going to be important. Perimeter, what is perimeter?
When you add up all the sides.
When you add up all the sides, doesn't matter what shape it is, right?
No.
Except a circle. Can you add up all the sides of a circle?
Oh, yeah. I mean, yeah, but it only has
Well,
one side.
Actually, it has infinitely many sides, technically.
Well, couldn't you technically add up a circle because every circle is not perfect? I guess no.
It's not a circle.
But every circle isn't perfect, though, isn't it?
No, if it is a circle, it is perfect. If it is an ellipse, then it isn't. Like, every square is a rectangle.
Yeah.
Not every ellipse is a circle.
Gotcha.
But humanity can create a perfect circle. So
Yeah.
technically.
Okay, corresponding lengths in similar polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the polygon. Okay? The ratio of any two corresponding lengths in the polygon is equal to the scale factor of the polygon. And I've been interchanging ratio, proportion, scale factor, haven't I? They all go together. Now, the first example, we are going to do more than just what the directions say on it, because when I was reading your worksheet, it asked you to do some things, and I'm like, oh, I forgot to give an example on here, so we're just going to use our first example to do it. Is everyone ready to move on?
Sure.
Okay. So we have two shapes, and it says determine if they are similar. So once we determine they are similar, then we're going to go on and do some other things with it. Okay? If they're similar, they want the scale factor. So in order to tell if they're similar, they have to have the sides have to be all the same ratio, correct?
Yes.
Yes?
Is this like technically like a reflection?
No, not this one.
Okay.
No. This would be a dilation. If they're similar, dilation means it either gets larger or smaller, but it doesn't change. Okay, so I always like to start, usually I'll just start from left to right. It doesn't matter. I could start from right to left. Doesn't matter, okay? I like to start left to right and with the smallest length aside. So 9 corresponds to what?
8. You're talking about on the other
9
12.
DG corresponds to
J.
JM. How do I know that DG corresponds to JM?
Because they're the same.
Look at the
I
angle.
can't trust the picture, but I can trust the angles, correct?
It does tell you.
And D and J are congruent, yes, and G and M are congruent, so I know those side lengths should be proportional. So 9 to 12, and that has to be the same ratio as 12 to 12, GF to 16, and then 15 to 20. Now, again, it doesn't matter if I would put D, E, F, G in the numerator or J, K, L, M in the numerator. It doesn't matter, but all the way across you have to have the same polygon. Does that make sense?
Sure.
9, 12, 15 are all in the left polygon, correct?
Yep.
Okay, 12, 16, 20 are in the right polygon. It doesn't matter which one's which, but it has to be in the same. Melissa and Connor, can you please put your heads up? Melissa,
You should let me wake her up.
you need to take notes, please. Okay, so what do I need to do with these ratios?
Make them all equal.
You need to like reduce them.
I need to reduce them, right?
Come out
Because the
with
first
3.
9 and 12 reduced by what?
3/4.
3. So I get 3/4. Okay, 12 and 16 reduces by?
3/4.
3/4.
No, it doesn't reduce by 3/4. It reduces by 4 to get 3/4.
And then the next one reduces by 5.
And the next one reduces by 5, and I get what?
3.
3/4. So my scale factor is what?
3.
3/4. Okay, so are these two similar?
Yes.
Yes. Okay, we are going to write a similarity statement. And we are also, it says write a similarity statement, find the scale factor. We are also going to write a statement that says all the angles that are congruent and all the sides that are corresponding. Okay? What?
What would happen to that 8 then between K and L?
We'll find that. We're going to find it in a minute. Okay? Yeah, because we don't have anything to pair that 8 with, do we?
Nah.
No, but we're going to find it because we can do it with our proportions, right?
3/4 would be 6.
Okay. So, what angle, and I'm going to write congruent angles. Okay, your worksheet, the first 4 problems says state the congruent angles and make corresponding side ratios. So what we do right here in the next step are exactly what your first 4 problems are asking for, okay? So congruent angles. So angle D is congruent to angle what?
J.
J.
G to M.
Angle E, I'm just going around, is congruent to angle what? K. Angle F,
Was congruent to L.
and you have to have the angle symbols there, right? Oops. And angle G is congruent to angle M. Okay, so those are my congruent angles, correct?
Sure.
Okay, so now we have our side ratios. Okay, so side DE corresponds to side what?
JK.
JK. That's just a comma. Then EF corresponds to
KL.
KL. And FG corresponds to LM. And DG, JM. Okay, could I have put the right polygon sides over the left polygon sides? Could I have reciprocated all of those?
Sure.
Yes, and it would just be perfectly fine. So your first 4 problems, they're gonna ask for your congruent angles and your corresponding sides. That's all they're asking. That takes the longest out of the whole worksheet. Okay, so for this problem, we've got the scale factor. We need to write a similarity statement, and we're gonna find EF just to finish it out. So how we write similarity statements is we list the angles in corresponding order. So what I do is pick one and put it in alphabetical order. So I have D, E, F, G. If this was a triangle, I'd put a triangle in front of it, correct? But it's not a triangle, it's just a polygon. Is similar. What is that symbol similar to?
JKML.
No. What's the symbol like? Where have we used that symbol before? Congruent. It's the top of the congruent, right? Okay, so what angle is congruent to D? J. What angle is congruent to E? K. What angle is congruent to F? L. What angle is congruent to G? M. So there is my congruence, my similarity statement. Right there. Now, what is nice about these similarity statements is it will just tell you this and it won't give you a shape.
Yeah.
It will just tell you this. It will say this polygon is similar to that polygon. And here's some side lengths. Find the scale factor. And you have to draw some polygon. Okay? If it has 4 sides, it's, Colorado, right? But how do you know what goes with what? Well, when I look at these similarity statements, do I know what angle is congruent to what angle? Yeah. Because the first angle, D is congruent to what? J. E to K. F to L. G to M. So then that also tells me what sides are corresponding. So DE corresponds to what? JK. EF corresponds to KL. FG corresponds to LM. DG, because you have to close it, right? It's not a polygon unless it's closed, is corresponding with what? JM. So we just went around that polygon, didn't we? Those similarity statements tell you more than just the name of it. They tell you everything about it. What angles correspond, what angles are congruent and what sides correspond. So, how do you guys want to find EF? We have a scale
We
factor.
just put 3 folds.
How about we just take 3/4 of 8?
Yeah.
Is that all we have to do?
Yes.
Yeah? So,
6.
EF equals 3/4 of 8, and that's 8 over 1, right? So 4 goes into 4 once, 4 goes into 8 twice, so the answer is 6. Now, could I set up a proportion like we've been doing? Could I? I could do x over 12 equaled 8 over 16, right? Multiply by 12. What's my answer? 6. You guys notice I never multiplied x by anything? If x is in the numerator, you never have to bring over, you never have to complete your cross product because you just bring it back over anyway. If x is in the numerator, you never have to complete your cross product. You can leave your denominator there. Yes?
Is the bottom one by like 8, 16? Is that 16 or 10?
16. Is it too small on your paper?
No, I can't see it.
On your paper. It's the same number on your paper. Is it too, can you read it on the paper?
Yes, but did you cross out the 2 or you left the 2?
Oh, up top. I multiplied by 12 on both sides. I put 8 into 8. 8 into 16 was 2. 2 into 12, 6.
Okay. Yeah, I was like, I couldn't read.
I thought you were talking about on the picture. I'm like, is the picture too small? Okay.
Yeah, it is.
So use similar polygons. So now, if I didn't have this picture, and they told me this, what shape am I having? What shape is this?
Triangle.
Triangle. How do you know?
It's
Okay, that's a triangle, right? And there's 3 sides. Okay. What angle is congruent to A?
P.
P. B.
Q.
Q. C. R. What side corresponds to AB?
Q.
PQ. How about AC?
Q.
A, C, P, R. Woo. BC is QR. Can I do them backwards also?
Yeah, you can.
Yeah,
There's
good.
no-
Okay, so it says find the value of X. So we know they're similar, right? So we can just find a scale factor. So what sides would you like to use to find your scale factor?
14 over
AB and
X.
AC.
We don't have X yet.
No, we don't have X yet. So what side do you want to use?
AC. We do 15 over.
You want to do
No,
22.5?
never mind. No.
No.
We'll do 6 over 9.
6 and 9?
Yeah.
Here's a helpful hint. Whatever you want, whichever shape you want, put that value on the top.
So like 3 or?
So I want the X in this triangle, yes? So what value is it with X? 9. So whatever you want, put that number over on the top. That's a helpful hint. And I'll show you why in a second.
So it'd be 9
So
over 6.
9 over 6. So 9 over 6 would be what?
It'd just be
3 over 2. Okay? Now if this is going from here to here, yes? Okay? What if I went from here to here? What would my scale factor be?
be the same.
No, it wouldn't. It would be 6
2/3.
over 9, so it would be what?
2/3.
2/3. Now, this is why you do this. I'm going to go from small to what? Big. So am I going to multiply by a number less than 1?
No.
No, it needs to be what? Bigger than 1. So whatever you want, put in the numerator. Got it? Because then you don't have to remember to reciprocate it on your own. You just already did. Okay, so how do I find X? I take what? 3/2 of 14. And 14 is over 1, right?
Mhm.
And 2 goes into 14? 7? So 21. Now we're not looking for a proportion statement, we're not looking for a scale factor, we're not looking for a ratio, so do I have to put it over 1?
No.
No. If I was looking for those other things, would I have to put it over 1?
Yes.
Connor and Melissa. Again. Okay. Why don't you sit up, Melissa? It might be easier to stay awake.
I wasn't done. Yeah, it
You
was.
weren't done?
I was sitting here writing these notes like a good response.
How rude.
Oh, I guess I just won't write notes.
Devin, please stop.
Yeah, Devin, if you could just stop.
Yeah, Devin, can you just.
Gentlemen, I'm sure the people listening to the video don't want to listen to you. Devin, let me know when you're done.
I'll tell for on that thing. I'll be a YouTube star.
Are you good?
Jake Paul next year.
Okay, so we're going to do one more and then you're going to do one by yourself. And it gets a little tricky. It talks about perimeter. So you'll do the scale factor by yourself and then we'll do the perimeter part. Okay, so find the scale factor and then find A. Just basically actually, why don't you just do this one by yourself? You ready to do one by yourself?
No.
No?
Yes.
No.
Try it.
One more together.
One
Pretty
more
stupid.
together?
So.
Okay,
As long
So
as
again-
together.
if I read that similarity statement, do I know what sides are corresponding with what sides and what angles with that angles?
Yes.
Yes. Okay, so we are going to go, we want A. is A gonna go smaller? Well, actually, it doesn't matter. Let's just put A, the STR in the numerator of my scale factor, right? Okay, so they tell me it's similar, so I don't have to check them all out if I don't want, but I'm going to just for practice, okay? So 45 corresponds with what in the other triangle? 50. So that should equal the same as 27 over what?
Over 30.
30. And the same thing will equal A over what? 40, right? So 45 over 50, what can I reduce it by?
5.
5? So it'd be 9 tenths.
Yes, ma'am.
3. So it'd be what again? 9 tenths. And so this is still going to have to be 9 tenths, right?
It has to be.
It has to be 9 tenths. Has to be. And that's an A. But
I mean, you just set up the
it's going to be
equation.
9 tenths. But my A's are looking like plans. So what is my scale factor?
You have to set up the equation.
9 tenths.
Ugh.
So I'm going to have A equals 9 tenths of what? 40. And again, that's 40 over 1, correct? So 10 goes into 40 how many times? 4. So I get what? 36.
Oh, can do that.
So my scale factor was 9 tenths, right? But I had, it's an A, right? So in order to get 10 to 40, what did I have to multiply it by? I got my 9. 4, right?
Yes.
So 9 times 4 is what? 36. You don't have to write this here if it's going to mess you up. I just wanted to show it to you, okay?
Okie dokie.
I like to do more than one even though I only have to do one because that makes sure I'm doing my math right. Because if it tells me it's similar and I don't get out 9 tenths in both of them, did I do something wrong?
Yeah.
Yeah. Maybe I flipped one, maybe I reciprocated one and not the other or something like that. Okay, now try the other one. The scale factor, and we'll do the, if you want to try the perimeter, go for it. But do the scale factor by your own. Your picture is better than mine because I fixed your notes. I don't know what happened when it copied. Bryce, you got a scale factor?
Yep.
Okay, how'd you do it? What'd you put over what?
Put 8 over 8. Wait, no, that's not.
8 and 8 don't correspond, do they? Now this shape's different. I can't just look at my shape and see, can I?
Oh.
I have to use my word, don't I?
It would be 8 over
So AB corresponds to what? FG. And the only thing I have is JF, don't I?
Yeah.
So JF corresponds to what?
DA.
DA. So I'm gonna want this, right? So I put it on top. I'm looking for the stuff in the smaller one. Okay. So I'm gonna have 8 over, and what's DA?
Well,
12. So with that picture, it was really hard to tell what corresponded with what, right? And we shouldn't trust our pictures unless they got some angles on there. So what's my scale factor?
2/3.
2/3? Because you reduced by what?
4.
4. Okay, so what is perimeter of any object again? How do you define it?
Add all the
Add of all the sides. So how am I going to find the perimeter of FGHJ?
You take 2/3 times the
number.
AB, or by the numbers on
15,
the page.
12.
Okay, so Connor wants to take 2/3 of 15, 12, and 10, find that, and then I'll add it up. Okay, we can do that.
Wouldn't it be 15, 8, and 10?
Out of all.
Oh, yes, I'm sorry. 15, 8, and 10. Bryce, you got another way?
add up all the sides and then you take 2/3 of that.
Can't I just add up all the sides of what I already have and take 2/3 of it? Okay, because that's your perimeter theorem that says that then the ratios of their perimeter is equal to the ratios of the corresponding side lengths. Wouldn't that be easier? Less room to make mistake, right? Okay, so 8 and 12 is 20. 10 is 30. 15 is
45.
45. Remember, capital P is the variable we use for perimeter, right?
Yes.
So the perimeter of FGHJ equals what of 45?
2/3.
2/3
So 30.
of 45. And remember that 45 is over 1, right? Does 3 go into 45?
Yeah.
15 times. And 15 times 2 is 30. Okay? So what you said would work, Connor.
I swear I always pick like the one that always takes the most work.
But that would take a lot of work, and then I'd open myself up to make more mistakes. So we always want to keep it as basic as we can. Questions, guys? So remember the first part of your worksheet, you're just writing the angles in that. Really quick, you only have to do 1 through